Okay. Did I give you all a paper? Hey, can you pass that on? Thank you. Did you pass yours? Everybody have it? Okay. So today we're going to work on something that I think you guys probably have done before, except maybe like the last three problems. You maybe haven't done those. But we're going to work through six of them together, and then obviously the six that remain will be your homework assignment for tonight. Okay? So here's what today's lesson's about. In math, sometimes words, of course, indicate what we would call mathematical operations. And y'all are familiar with this, okay? If I say plus, you know what I'm talking about, right? What does plus mean? Addition. You're adding, okay? There's all kinds of different words that we could use for adding. What are some others that you guys are familiar with? Increase by some, right? Anybody else? They might actually use the word added by, added to, something like that. Okay, how about subtraction? What are some words that you guys are familiar with for subtraction? Decrease by, or maybe you run into that word. I don't know if I've seen that one a lot. I think I heard someone say decrease, difference, subtracted. Now, here's the difference though. When it comes to addition, order doesn't matter, right? What's 5 plus 7? 12. What's 7 plus 5? 12. Same thing, right? Order doesn't matter in addition. But what about subtraction? Does order matter? Yes. What's 5 minus 7? What's 7 minus 5? 2. 2 and negative 2 are not the same answer. So with subtraction, you have to be a little more careful. For example, if I say subtracted from versus subtracted by, are those different? Absolutely. They're very different. Subtracted from and subtracted by are very different. So again, when it comes to subtraction, you got to be a little more careful because order matters. Now, what about multiplication? What are some words you're familiar with for multiplication? Product, times. You could use specific words like twice a number. That means multiplication. It means you're multiplying by 2. Double would be the same thing. Multiplying it by 2. So there's different words. Now, with multiplication, does order matter? No. Not at all. 2 times 5, 5 times 2, same thing. Now, the last mathematical operation, there's more things like exponents that are kind of a different operation, even though they're kind of still the same. But you have division, which is more like subtraction in that order is important. So the way you put stuff is very, very specific. Now, what are some words for division? You'll see divided by. You'll also see quotient. Sometimes you might even see something like half of something. Like if I say half your age, what could you do to your age? You could divide by 2. So that could indicate division. It also could indicate multiplying by 1/2, which is the same thing as dividing by 2, but it gives you that option. You understand? So words have mathematical meaning. Now, what we're going to do today is we're going to take those words, we're going to accumulate these equations, so we bring in another terminology for equals. Okay, and there's some different things that you'll see, but we're going to write the equations, and then we're going to solve the equations. So like I said a second ago, I'm going to do 6 with you, and then tonight you're going to do the other 6. Hopefully it won't take us the entire class time. You'll have some time to work on this. We're going to start with number 1. I'm going to do, in case you want to kind of work ahead, I'm going to do 1, I'm going to do 2, I'm going to do 4 because it has to do with golf, I'm going to do 5, and then on the back side, I'm going to do 8 and 10. Okay? Those are the ones that I'm going to go with you through. Now, as far as the ones that leaves you with, I would like that you do pay attention because I wouldn't say they progress, but some of them are different. So the ones I'm leaving you to do, it might be more like number 4. It might be more like number 1. So I do need you to pay attention, but also if you choose to, feel free to work ahead, okay? We're checking those doors every day. All right, so number 1, the product of 7 and a number increased by 3 is equal to twice the number subtracted from 39. Find the number, okay? So sometimes when you read these word problems, they're a little overwhelming. So that's why it's good to just kind of slow down, break them into pieces. So let's do that. The product of, what does that mean I'm doing? I know I'm multiplying. So I immediately say, okay, what does it tell me it's the product of? 7 and a number. Now, whatever the number is you choose to define is your call. Most of the time we use either n, because the number, or sometimes we use x. Most of the time, probably x. I don't care what y'all want to use. What do y'all want to use to define as the number? X. Okay? So, the product of 7 and a number looks like what? 7x. Okay? Next part of this. Increased by 3. What does increased by mean? So we're adding 3. Increased by 3. And then it says is equal to, so that's where my equal sign comes in. And now we're looking at the other side of this thing. So let's see what's on the other side. It immediately says twice the number. Again, that was mentioned just a second ago. When you see twice the number, it's indicating you're doing what? You're multiplying the number, which we've already defined as x, you're multiplying it by 2. So twice the number. Now, again, I just made a little bit of a mistake. If I have a pencil, it's no problem. If I have a pen, it stinks. Because, what's the very next thing that said? Subtracted from. Okay? See my mistake? I didn't leave myself enough space. Subtracted from means, where does 2x go? It goes after the 39. Because it's being subtracted from it. So again, with subtraction, remember, order is important. If that is said subtracted by, it would have been the exact opposite, wouldn't it? It would have been 2x minus 39. But it didn't say subtracted by, it said subtracted from. So please be real cautious when it comes to subtracting or dividing. Your order is extremely important, okay? Y'all with me? Now, from here, it's just the process of solving, which we did last week. You've done a ton. There's nothing to simplify on the left. There's nothing to simplify on the right. But there are variables on both sides. Which one do I like to move? The 7x or the negative 2x? That's what I would move. How? I would add 2x. So 7x plus 2x is? So 9x plus 3 equals 39. And then, of course, we're just to step 4, solving the equation. We're going to first subtract 3. So 39 minus 3 is? And then we're going to divide by 9. What's 36 divided by 9? So our number is 4. And that's it. That's all there is to it. It's not too bad, right? Not bad? Okay, let's move along. And immediately we run into probably one of the most missed problem when it comes to word problems. Immediately you look at this problem and you see less than, right? And you associate less than as what? Subtraction. So a lot of times when people look at this problem and they see 5 less than, and they associate less than with subtraction, they go 5 minus. But that's wrong, isn't it? Because think about this. Let's go with something that's just logical, like ages. Let's say you have a younger sibling, and your younger sibling is 3 less than your age. If you're 16, does that mean that your sibling is 3 minus 16? No. Your sibling's not negative 13 years old. It's impossible. Now, you would go your age minus 3. That makes logical sense when we think about it like that. So let that make logical sense when you write the equation too. If it says 5 less than something, what does that mean you're actually doing with the 5? You're subtracting that 5 from something. Okay? So kind of put that one in your memory banks because that's one of the ones we get mixed up quite a bit. Remember, with subtraction order is important. With the less than, whatever's in front, 5 less than, it means you're subtracting it. Okay? So keep that one in your mind as we move forward because you're going to see that quite a bit. But what is 5 less than? Twice the number, which we would define as 2x. So that side's going to look like 2x minus 5. But then it immediately says is equal to. So that's where I put my equal sign. Did y'all hear like a huh? I wonder what that is. Okay. Next. Y'all hear that?
Yeah, I hear it.
It's kind of getting on my nerves. Okay. Next side. It says 1/2 the difference of. Okay, so listen. If I were to say 1/2 of a number, that's 1/2 x, right? Or how else could we do 1/2 of a number? I could do 0.5x. There's one other really good way. If I did 1/2 of a number, I could do x divided by 2. Those are all 3 really good options. 1/2 x, 0.5x, or x over 2. But it doesn't say that. It says 1/2 the difference of. So what they're about to do is they're about to give me a quantity that you have to do half of. So when I see something like that, I usually either think parentheses if I'm doing 1/2, or a fraction if I'm going to do divided by 2. You understand? Now it's your call. Would y'all rather do 1/2 of a quantity as like 1/2 with parentheses, or would you rather do 1/2 as some fraction bar over 2? Parentheses? Okay, so I'm going to do 1/2 a quantity. And what's happening in that quantity? What word did they use is happening in that quantity? Difference. Difference. Difference means we are subtracting. Now, we're going to follow the order of what it's doing the difference of. So what's it doing the difference of? 3 times the number. How do I say that? 3x and what? 13. So there you have it. There's your equation. 2x minus 5 on one side, and then 1/2 times 3x minus 13 on the other. The reason or the way that I remember that it's a quantity is because it said half the difference of. So it's telling you that you're doing half of something that's about to happen. And that thing that's about to happen has to happen first. And because it has to happen first, I use parentheses. Now listen, let me just show you. Because y'all told me a second ago that you could have done 0.5 here instead of that 1/2. But you also said you could have done 3x minus 13 on top over 2. Okay, that's what Brody said works just as good, and I agree. That works just as good. Okay? Because either way, whether I'm solving it using that top one or whether I'm solving it using the bottom one, what's my first step in solving? What are you going to do first? You're going to multiply by 2. Remember, because we don't divide by 1/2, that's a fraction. Instead, we multiply by the reciprocal, which is 2. So either way, however you wrote that equation, you're still going to multiply by 2 first. Now, when I multiply by 2, I have to multiply that entire side by 2, meaning I've got to use distributive property. So here we go. What's 2 times 2x? And what is 2 times negative 5? And then on the other side, of course, that 1/2 and that 2 canceled each other. And that allowed the 3x minus 13 to just drop straight down. Which one am I going to move, 4x or 3x? Yep, I like moving the smaller one, so I'm subtracting 3x from 4x. What's 4x minus 3x? So 1x, or x, minus 10 equals negative 13. My last step? Add 10. So I'm either going to, in my brain, or my calculator, go negative 13 plus 10, or remember I like to do it in my head, 10 minus 13. What do I get? Negative 3 is my answer. Okay?
I did that a lot.
Me too.
Did you?
I didn't do that distributive property, where you multiply by 2. I just did 1/2 of 3 and 1/2 of 13.
That's fine.
Because they're both end up in half.
Yeah, no, that's perfectly fine. The only reason that I probably wouldn't have done it that way is because most people don't like working with fractions. But then you probably turn them into decimals or no?
Yeah, they're both 0.5 and 1.5. So.
Yeah, that's perfectly fine. Perfectly fine. Okay? It's just most people don't like working with decimals, so, well, really most people don't like working with fractions, so I usually avoid things that cause you to work in fractions. But you absolutely could have done that problem that way. Okay? Any other questions? Okay, starting number 3 and 4, it changes gears just a little bit, the way the word problem is worked. Let me explain. Look at number 4. We're going to skip 3. Y'all can do it on your own. It says Kara's golf score was 1 less than 3/4 of Greg's golf score. And then, of course, the rest of it says, if the sum of their scores was 153, then find Kara's golf score. Here's how it changes gears just a little bit. In this problem, all of a sudden, it's actually comparing 2 things, right? Look, Kara and her golf score is being compared to whose? So here's the deal. When we see that, when you have something being compared to something else, do you know what that something else is? Yeah, you do. It's something. And what do we call something in math? We call it x. So since Kara is being compared to Greg, Greg is what? Greg is x. He's something that we don't know. And Kara is being compared to that something that we don't know. So that thing that we don't know, we know is x. All right? That sounded confusing, but now that we know that Greg is x, we can define Kara, can't we? Because it says that she's 1 less than. Remember how that worked? How do we do 1 less than? We do something minus 1, right? So she's 1 less than what? 3/4 of Greg's score. And we define Greg as what? So she's 3/4 x minus 1. She's 1 less than 3/4 Greg. So 3/4 x minus 1. Does that make sense? Now that we've compared these two, and we have equations for both of them, Greg being the one that everyone was compared to, x, and then Kara now, who's 3/4 x minus 1, what does it say about their scores? What equals? Their sum. So what are we doing with these two equations? We're adding them and setting them equal to 153. So we're taking 3/4 x minus 1 plus x. Okay, there are 2 scores. And we're adding them and setting them equal to 153. Does that make sense? So the key here is understanding when you have things being compared to each other or other things, you've got to define something first, and then that will allow you to go from there. All right? Now, from this point, it's pretty simple. You're just combining like terms. That's the 3/4 x plus the 1x. And y'all could write that a couple of different ways. Some people probably turn them into decimals. 3/4 is what? So 0.75x plus 1x is what? You could do 1.75x, or if you use your calculator and you did 3/4 plus 1, it would actually make it 7/4. 7/4. And that works too. So 1.75x or 7/4x, and then don't forget the minus 1 equals 153. Now let's solve. What's the first thing I need to do here? Add that 1. So either 7/4 x or 1.75x equals 154. Now what? You're going to divide by 1.75, or if you had 7/4, you're going to multiply by 4/7, the reciprocal. Either way, you get what? Feel free to use your calculators. You'll have your name attached to one now when you come in. Feel free to grab it. 154 divided by 1.75 equals 88. So what does that mean, y'all? Who was 88? Who was 88? Greg. Greg's score was 88. So how do I find Kara's?
153.
Yeah, you can do that. 153 minus 88. What's that?
65.
65? What else could you have done? What else could you have done besides 153 minus 88? Yep, plug it into her equation. 3/4 of 88, 66 minus 1, 65. Needless to say, Kara's a good golfer. For you guys who don't really know golf, that's pretty stubborn.
Can you shoot a 65?
Yeah, I've done it. I did it this summer. My lowest is 63. Ever. That's 9 under par.
How many mulligans?
None. I don't take mulligans. Okay, any questions about this one? Alright, let's go down to number 5. Sometimes the problems that you work, sometimes they include you needing to know a formula. Be familiar with a formula. Okay? For example, in this problem, it says the length of a rectangle is 1 more than 4 times its width. We'll worry about that in a second. If the perimeter of a rectangle is 62, y'all know perimeter, right? Find the dimensions of the rectangle. Okay, so understanding a little bit about a rectangle. Do you happen to know the formula for perimeter of a rectangle?
Yes.
It's length plus width plus length plus width. But what else could you do?
2L plus 2W.
Yeah, 2 L's, 2 lengths, plus 2 W's, 2 widths, will equal that perimeter. So whether you just add them all up, or whether you use that formula 2L plus 2W equals perimeter, it doesn't matter. Now, what does matter is you got to have the right equations or expressions for the length and the width. So what I immediately do is we figure out what is being compared to what. In this problem, what is being compared to what?
Length is being compared to width.
The length is being compared to the width. Does everybody agree?
Yeah.
Then if the length is being compared to the width, then the width is what? That's my x. Okay? You find the root. What is things being compared to? That is something. Something is x. The length is being compared to the width. The width is x. Now we can define the length. It's 1 more than. How do I do 1 more than? 1 more than. You add, right? Could you do 1 plus or plus 1?
Yes.
Doesn't matter, does it? Which one would y'all prefer? 1 plus or plus 1? Plus 1? Okay, 1 more than what? 4 times the width. And we call the width what? So 4x plus 1. Or 1 plus 4x. It doesn't matter. We generally put the variable first, but it doesn't matter because it's adding. And order doesn't matter when you add. So you have 2 options. Now that you know you've got these defined, you can write your equation, or you can just add up all 4 sides. 2 of those sides being 4x plus 1s, and 2 of those sides being x. So if you were to use the equation 2L plus 2W equals the perimeter, and they defined the perimeter, told us the perimeter was 62. Now, what would I do if I use this formula? Now, what property? Yep, what's 2 times 4x?
8x.
What's 2 times positive 1?
2.
So 8x plus 2 plus 2 times x is 2x equals 62. Combine your like terms. What is 8x plus 2x? So we've got 10x plus 2 equals 62. All right, what's 62 minus 2? And then lastly, we divide by 10. So what equals 6? X equals 6. But what is that? My width is 6. And my length is 4 times 6 plus 1. So my length is 25. So my perimeters are, my dimensions are 25 by 6. And I guess these are meters. 25 meters by 6 meters. Again, in all reality, you're supposed to do all that, but my concern is you getting to that answer. Okay? What do you think? It's not too bad, right? All right, let's step it up one more level. Okay? One more level. Let's go to the back and look at number 8. Why is this stepping up one more level? More what?
More reading.
And more reading?
None of these are just
More people.
a value.
Huh?
None of these are just a value.
Right. You got more people. Well, no, I don't. No, that's not right. Let's see before we answer that. You got Kelly. You got Laura. And you got Tia. Now, let's see what it shows me. They sold boxes of cookies for a fundraiser. All right. Kelly sold 15 boxes less than Laura. Okay, so who's Kelly being compared to? Laura. Right? Next sentence says Tia sold twice as many boxes as Kelly. So who's Tia being compared to?
Kelly.
Tia is being compared to Kelly, and Kelly is being compared to Laura. So therefore, what do you know?
Kelly.
Laura. Always go to the root. Who is everyone being compared to essentially? Laura. See, Kelly's being compared to Laura. Tia's being compared to Kelly, but Kelly's being compared to Laura. Laura is X. She's the top dog. Not really, though. At the end, you'll see somebody sold more boxes than Laura. So technically not the top dog, but the top dog when it comes to writing the equation. Now, let's go from here. Kelly sold 15 boxes less than Laura. X minus 15. Very good. I'm going to keep throwing that less than term in there because that's the one people mess up on all the time. It's not 15 minus X. It's X minus 15. Okay? And then lastly, it says Tia sold twice as many as Kelly. Well, what did Kelly sell?
15 less.
Kelly sold X minus 15, right? So Tia sold 2 times X minus 15. You can't change Kelly's expression. X minus 15 is Kelly. Well, if Tia sold twice Kelly, she sold 2 times X minus 15. You understand? Now, how do we solve this problem now that we've defined them all? That's right. They all sold a total of 83 boxes. So we simply add all of these up. So I'm going to take Kelly, who sold X minus 15, and I'm going to add to her Laura, who sold X, plus I'm going to add to her Tia, who sold 2 times X minus 15. 2 times X is 2X, and then 2 times negative 15, and all of that is a total of 83 boxes. So I'm going to combine my like terms. I think that's what you were doing, huh, Katie?
Yeah.
X plus 2X is
4X.
And then negative 15 minus 30, negative 45, and that equals 83. I'm going to, what? I'm going to add 45. 83 plus 45 is 128. And the last step, we're going to divide by 4. What is 128 divided by 4? 32. So, Laura, who was X, sold how much?
32.
She sold 32 boxes. How do I figure out how many Kelly sold? 32 minus 15, which is 17. How do I figure out how many Tia sold? 2 times Kelly. 2 times 17 is
14. 34.
34. Yes, sir.
I made Kelly X, like I believe X.
Okay, so you would have put Laura's equation as X plus 15? Okay,
And Tia was 2X.
2X. That works too.
So it's 4X plus 15 equals 8.
Yes. It just defines 17 as X. Yeah, that's fine. The only reason I maybe wouldn't have gone that route is because then you have to change the equations because it said that Kelly was 15 less than, so you just have to reapply that to Laura being 15 more than. Does that make sense? Yeah. But perfectly fine. Okay? Perfectly fine. Any other questions? Okay, then the last concept that I want to talk to you guys about is the concept of consecutive. Okay? Consecutive. Now, when it comes to consecutive, there are 2 different possibilities. It might just say consecutive integers, but it might say consecutive even or odd. And these 2 you treat the same way. Okay? So real quickly, here's what I need you guys to do. Somebody just tell me 3 consecutive integers. What does that mean? Consecutive means one right after the other, right? So somebody give me 3 consecutive integers. 4, 5, and 6. Now, if I were working a problem, they wouldn't tell me what the consecutive integers were. Okay? They would just say, hey, you have 3 consecutive integers. And therefore, we have to define them. So here's how this works. If I don't know what that first one is, what do I define it as? I define it as X. Now, if I know that the first one is X, how would I define the next one?
X plus 1.
I would do X plus 1. How would I define the third one?
X plus 2.
X plus 2. And I could keep doing this all day, right? The next one would be, the next one would be, you see, we could keep doing this as many as we needed to do. So when I do consecutive integers, I use this method right here. Okay? Now, let me do the other one. Somebody give me 3 consecutive even integers. 2, 4, and 6. And somebody else give me three consecutive odd integers. 3, 5, and 7 were the first I heard. Now listen, a lot of times people view these as them being different because one says even and one says odd, but they're absolutely not different at all. Let me explain. If I were defining the very first term, I don't know what the very first one is, do I? So what would I call the very first one? I would call it x. If I was doing consecutive even or consecutive odd, I would call the first one x. Now, whether I go from 2 to 4 or 3 to 5, how many do I go up? I go up 2. So how would I define the next consecutive even or odd? X plus 2. How would I do the next consecutive even or odd? See, people think that you need to treat these differently because one's even, one's odd. But you don't. Because if you just try to go up 1, then you're only going up 1. But to get from 1 even to the next even, or 1 odd to the next odd, you're going up 2. So this is what we use for consecutive even or consecutive odd. Okay? Pretty simple concept. But it's one that I don't think you guys have probably seen yet. So we can solve any of these last 3 problems really without any trouble if you understand this. Look, the sum of 4 consecutive integers. So which one am I using, guys? Am I using left or right for 4 consecutive integers? I'm using the left one. X, x plus 1, x plus 2. But how many did it tell me to do? It told me to do 4 of them. So I'm doing x. I'm doing x plus 1. There's 2 of them. I'm doing x plus 2. There's 3. I'm doing x plus 3. There's 4 of them. You see, every time I just went up 1 more. And I take all of these and add them together. And that will equal what in this problem? 222. That's how easy these problems can be. Okay, they can be real easy if you understand that all consecutive integers are x, x plus 1, x plus 2, x plus 3, x plus 4. All consecutive even or odd is x, x plus 2, x plus 4, x plus 6, x plus 8, as far as we have to go. It's pretty easy, isn't it? All right, now we're just solving. And that means combine our like terms. So there's an x, there's an x, there's an x, and there's an x. So x plus x plus x plus x is 4x. And then we got 1 plus 2 is 3 plus 3 is 6. So 4x plus 6 equals 222. And now look at us. We've got a simple problem that just needs to be solved. I subtract 6. What's 222 minus 6? 216. And then lastly, we divide by 4. 54 is the first of our 4 consecutive, right? So what are my 4 consecutive? 54, 55, 56, and 57. Listen, I always like to go back and just add those up real quick and make sure they equal what? Just double check it, just to make sure you did your work right. Okay? But that's it. That's how you do consecutive integers or consecutive even or odd. Please don't think that consecutive even and odd have to be done differently. They're done the same because you still have to skip 2 to get to the next even or to the next odd. So it's really all about the first term. If the first term's even, skipping 2 gets me to the next even, and so on and so forth. Okay, questions about that? All right, so your homework are the additional 6 problems. All right, some of them will be just cake, and then some of them you might have to think a little bit more, but you can do it, okay? You can definitely do it. Any questions? If you have some, while we got a little bit of time, I need my little calendar that has the schedule on it. Schedule. Not the calendar, schedule.